Hello geometry students, here's your lesson for section 3-6, lines in the coordinate plane with Missy McCarthy, math instructor at Okemos High School. By the end of this lesson, you should be able to say, I can graph lines and write the equations of lines in both slope-intercept and point-slope form if I'm given a point and a slope, or if I'm given 2 points. Should sound familiar from algebra. You should be able to classify lines as parallel, intersecting, or coinciding, and you should be able to write the equations for horizontal and vertical lines. So here's just a review from algebra of what an equation looks like if it is in point-slope form. So point-slope form is y minus y1 equals m times x minus x1. And in this particular equation, you can easily identify the slope, and you can easily identify a point on the line by finding x1 and y1. So x1 comma y1 will be a point on your line. It's a point on line. So here's an example here of what it would look like if you had the equation and what the slope would be and what the point would be. So we have y minus 3 equals 2 times x minus 4. So the slope we identified as 2, and the point would be 3, 4. Oh, they messed up there. This is your x1 and this is your y1, so that is actually wrong. The slope should be 2 for this one, and your point should be the x value is 4 and the y value is 3. So the textbook messed up on that one. Okay, you probably also remember from algebra the slope-intercept form of an equation, which is y equals mx plus b. So y equals mx plus b, where m still represents the slope of the equation, and b represents the y-intercept of the line. Okay, so if you look at this one, y equals 3x plus 6, the slope is 3, and the y-intercept is 6. So we're going to practice graphing those in just a moment. But lastly, we're going to look at the equations of horizontal and vertical lines. So if your line is a vertical line, the equation is always x equals some number. Here we have a representing that number, where a is the x-intercept. So x equals 5 would be a vertical line, 1, 2, 3, 4, 5. The x-intercept is 5, and there is our vertical line. So that's the line x equals 5. Similarly, for a horizontal line, it's always y equals some number b, where b is the y-intercept. So if we were going to graph y equals 2, 1, 2, my y-intercept is 2, and here is the line y equals 2. So there's no slope-intercept form or point-slope form when you have horizontal or vertical lines. Okay, so let's practice. One of those learning targets was to be able to write the equations if you're given the slope and a point on the line. And this time we're going to write it in point-slope form. So they told me that the slope was 6, so m equals 6. And they told me my point was 3, negative 4. So this must be my x1 and this must be my y1. So point-slope form is y minus y1 equals m times x minus x1, and I simply just need to plug everything in. So I would have y minus y1 is negative 4 minus negative 4 equals m, which is 6, times x minus 3. I don't like that double negative there, so my equation is actually going to be y plus 4 equals 6 times x minus 3. And that's the equation of that line in point-slope form. Now, can we find the equation of the line that goes through 2 points in slope-intercept form? There's a couple of ways to do this. The very first thing I'm going to do is find the slope, because whether I'm going to do slope-intercept form or point-slope form, I need the slope. So I'm going to do the change in y, 2 minus 0, over the change in x, which is 1 minus negative 1. So I end up with 2 over 2, so my slope is 1. Now, just to illustrate this, I'm going to start in point-slope form and then change it to slope-intercept form. You don't have to do that, but that's the way I like to do it. So I'm going to choose one of my points. The point that I am going to choose is the point 1, 2. All right, so I'm going to use that point, and I'm going to first write my equation in point slope form for practice. So y minus 2, that's the y coordinate of my point, equals the slope, which is 1, times x minus 1, because that's the x coordinate of my point. Now it said write it in slope-intercept form. This is in point-slope form, but it's easy to get to the other one. The first thing you got to do is the distributive property. So I have y minus 2 equals 1x minus 1, and then add 2 to both sides. And you get y equals 1x plus 1. And there's the equation of that line in slope-intercept form. Okay, so you got to know how to do that. It's one of our learning targets. Alrighty, lastly, we're going to write the equation of the line given in the given form. This line has an x-intercept of 3 and a y-intercept of -5, and we got to write it in point-slope form. So if the x-intercept is 3, then that means we can write, oops, my bad. If the x-intercept is 3, then that means we can write the point 3, 0. That's a point on the line. If the y-intercept is -5, that means we can write the point 0, -5. That's another point on the line. That's where it crosses the y-axis. So now we first have to find our slope. So I'm going to do y2 minus y1 over x2 minus x1. And I get a slope of -5 over -3, or 5/3. So that's my slope. And now again, when I get ready to write the equation of the line in point slope form, I just choose one of my points. It doesn't matter which one I choose. I'm going to choose the first one here, and I'm going to write my equation in point slope form. So y minus y1 is 0 equals the slope, which is 5/3, times the quantity x minus x1, which is 3. I don't have to write the 0 there. I could just write y equals, but this is okay too. Now what if you had chosen your other point? Then your equation would be y minus -5 equals 5/3 times x minus 0. Again, for either of these, you don't have to write the 0. You could just write y equals 5/3 times the quantity x minus 3. Or for this one, you could just write y plus 5 equals 5/3 times x. You don't need to put the zeros in there, but that's the equation of the line, and this is actually the same line. If we were to change them to point slope or to slope-intercept form, you would see that those were the exact same equation. So either of these answers would suffice. All right, when you're graphing the lines, there's 3 simple steps that you can use, whether you have it in point slope form or slope intercept form. First, you're going to plot the given point. Sometimes that point will be given to you in the equation. Other times it'll be the y-intercept, also given to you in the equation. Then step 2, you're going to use the slope to find other points on the line, and then you're going to extend the line and draw arrows on both ends. So let's practice graphing given 3 different forms of the equation. All right, so here's the first one, y equals 1/2 x plus 1. So we're going to graph this starting with the thing that they gave us is our y-intercept. That's the point that they gave us. That's the point 0, 1. So I'm going to plot that point on the line, on the y-axis. Then we're going to use our slope to get other points on the line. This slope says that I have to rise 1 and run 2. So from this point, I'm going to rise 1 and run 2, and I'm going to put a dot. You can do more if you want. Rise 1, run 2, rise 1, run 2, and then that gives you the points on your line. And then lastly, you extend your line and draw arrows on the ends. So first, plot the point they give you. Second, use your slope to get other points. And then third, connect your points and draw arrows on the end. Okay, we're going to try that again with an equation of a line in point slope form. This time, though, we're going to need the point by coming into the equation here. So first, I know my slope is -2. That's good. So now the point, I know it's y minus y1 equals m times x minus x1. So what's my x1 going to be? What would I have to subtract in order to get this to be plus 4? Well, I would have had to subtract a -4. So my x value is -4. My y value that I'm subtracting here, y minus y1, my y1 is 3. So first I'm going to plot that point on the line, -4, 3, 1, 2, 3. And that point is there. Now I'm going to use my slope, which is -2 Or I could also write it as negative 2 over 1 to go down 2 over 1 and put another dot. Down 2 over 1, put another dot. Down 2 over 1, down 2 over 1. Do it as many times as you feel like you need. Then draw your line and put the arrows on the end. All right, for our last example, we are going to graph a line. Is this one going to be horizontal or vertical? So it's y equals 3. So I'm going to go to, or negative 3. So I'm going to go to my y-intercept here and go to negative 3. Now, where are all of the points where y is always negative 3? It's actually a horizontal line that has a slope of 0. So that's how you graph the line y equals 3. If it were x equals, you would go to the x-axis and you would draw a vertical line. But this one is a horizontal line with a slope of 0. All right, so the last thing you're going to be able to do is tell whether or not pairs of lines are parallel lines, and we already know that if they have the same slope and a different y-intercept, they're going to be a parallel set of parallel lines. Whether the lines will be intersecting, that just means they have different slopes, or whether the lines will be coinciding. That really means just that they're the same line. One lies on top of the other, so they would have the same slope and the same y-intercept. So if we look at these equations here, we have to determine whether they're going to be parallel, whether they're going to intersect, or coincide. So the first set's not so bad. I'm looking at the slope here. This slope is 3. This slope is negative 3. They have different slopes, so according to the previous slides, these two lines would coincide because the slopes are different. For this one, I know that the slope is negative 1/3, but this one's not solved for y. In order to solve for y, I would have to divide everything by 6. Now my new equation is y equals negative 1/3 x plus, what is that, 2. So I see this one has a slope of negative 1/3 x plus 5, and this one has a slope of negative 1/3, but it's x plus 2. So they have the same slope and different y-intercepts. So that means that these two are going to be parallel. Same slope, different y-intercepts. This last one, I need to solve for y also to see what my slope is going to be. So I would add 4x to both sides. So I would get 2y equals 4x plus 16. Then I would divide everything by 2, and I would get y equals 2x plus 8. Okay, this one is not in slope-intercept form, so I have to get it there by distributing my 2. I get y minus 10 equals 2x minus 2. Then add 10 to both sides, and I get y equals 2x plus 8. So because they have the same slope and the same y-intercept, that means these lines lie right on top of each other, and they would and then we would call them coinciding lines, or we would say that those lines coincide. So actually for this first one, I actually messed up. Those are not coinciding lines. If they have different slopes from the previous slide, we said that these lines intersect. So intersect means different slopes. Parallel, same slope, different y-intercept, and coinciding lines, same slope, same y-intercept. Okay, we'll practice a ton more in class. See you then.